A few of you had asked me to review some algebra material that you guys had forgotten because it's been a while. So I figured I'd do that now. I'm going to work on the, we'll go over the answer to the diagnostic problem that I gave you guys before. That was the very long, complicated algebra problem. Now, just as some motivation for this, one of the nice things about solving problems algebraically is you don't actually have to plug into a calculator. So if you, basically you're just rearranging letters on a paper, and if you follow the rules of algebra, you get the correct equation. And another nice thing about that is you get to actually see the functional relationships. You get to see how things scale. So if I solve a problem and get an algebraic equation, that equation will be true no matter what numbers I plug in. So it's a more general solution to the problem. A better motivation for you guys is I will tell you that for tests, if you don't want to plug numbers into your calculator, if you leave things in terms of variables, I will give you full credit for that. So it'll save you some time on tests, just solving in terms of variables. So I'm going to go ahead, let's review what that problem was. I gave you an algebra equation. It was A equals B plus C to the D divided by E minus log F. And I asked you to solve this equation for B, C, D, E, and F in terms of the other variables. So we're going to go through how to do that. Now, to do that, it is helpful to remember the order of operations that we work with. So you may remember the expression, please excuse my dear Aunt Sally, which stands for parentheses, exponentiation, please excuse my multiplication and division, Aunt Sally, addition and subtraction. So when I'm looking at this problem, we want to bear in mind that there really is, even though we haven't written it this way, there's really some parentheses that are implied there. And we want to work with those parentheses first. So let's see if we can solve for this B. The first thing I want to do is remove move anything with parentheses over to the other side, paying attention to my order of operations. So what I can do, I'm not going to write this out every time. I'll do it the first time so you guys can see it. What I'm going to do is I'm going to say A equals B plus C to the D divided by E minus log of F. Now, let me just move my trash can out of the way, give myself more room. What I'm going to do, I want to move that, I want to get B by itself. I'm solving for B, which means I've got to move the E minus log F over to the other side. So the way we do it, if it's in the denominator on this side, I can move it up to the numerator on the other side. Why can I do that? Basically, I'm just multiplying by the same thing on both sides. So I have the left-hand side equals the right-hand side. Which means if I multiply by something on the left-hand side, I've got to multiply by the same thing on the right-hand side if I want it to stay equal. So what I'm going to do, let's multiply both sides by E minus log F. And then times E minus log F on this side. And on the right-hand side, that E minus log F will cancel out. On the left-hand side, I'm just going to get E minus log F times A. And then on the right-hand side, I'm going to get B plus C to the D. That's a good start. Now, all I have to do to get the B by itself is just subtract C to the D on both sides. And we'll be left with B on this side equals E minus log F times A minus C to the D. Now, you might have forgotten the rules of algebra, the please excuse my dear Aunt Sally. But if you remember them, if you get some practice using them, you see, all we did was just rearrange the letters on the paper. That saves us a lot of time. I didn't have to plug into a calculator. I didn't have to worry if I plugged in numbers correctly. I can I can just see by rearranging the letters that this is a lot easier than actually plugging into a calculator. Once we start dealing with actual physics equations, you'll be able to spot errors that way as well, because you just by thinking about what units each of the different physical quantities has, you'll be able to think, all right, are the units still working out here? And if they do, that's a good sign you did the math right. If you just plug into a calculator and you get just some number, then you're not going to be able to tell what the units are. You can't check using dimensional analysis whether the units are correct. So here we solved for B. Let's do the other cases, because some of the other cases are a little bit harder. Erase that over here. I'm going to actually go back to this step to solve for C. I already did a little bit of work. It's not worth me starting from scratch again. So let's start from that step right there. So we're starting from the step that says E minus log F, quantity, times A, equals B plus C to the D. I'm going to rewrite that. I'm going to subtract B on both sides. So I'll subtract a B here, and I'll subtract a B here. And when I do that, I'm going to get E minus log F times A minus B equals C to the D. Now, people tend to forget rules for exponentiation and logarithms. But it's helpful to think in terms of numbers, right? It's easier to think in terms of numbers rather than just algebraic variables. So how do I get C by myself if it's C raised to the D power? Right, well, if D was 2, that would be C squared, right? So if it were C squared, most of you will be able to tell me right away what you have to do. You've got to take a square root. If D were 3, a lot of you would still be able to tell me what you have to do. You have to take a cube root. Really, all we're doing is, since this is a D, rather than a square root or a cube root, we're taking the dth root of both sides. So what I'm going to do, to get the C by itself, I'm going to take the dth root of both sides. I've got to do it to both sides. When I do, since we have an equation, both sides are equal, left-hand side equals right-hand side. If I want it to stay equal, I've got to do the same thing on both sides. Right? So if you have two sets of identical twins, they're identical in every way. If you want them to stay identical, you've got to do the same thing to them. So if I give one twin a hat, I've got to give the other twin a hat. If I pull one of the twins' ears off, I've got to pull the other twins' ears off, right? Just to keep things equal. So we've got this. We've taken our dth root. That will undo or cancel out this C to the D power. So I'm just going to be left with C on this side. Oops. Sorry, this square root, this dth root should go all the way around because I'm taking the dth root of everything on that side. So I'm just going to be left with C equals the dth root. It's the dth root, not a square root. The dth root of E minus log F times A minus B. Okay. So dth root, let me just write that. Give myself more room just to explicitly show that we're taking a dth root here, just because I forgot to put it in the first time. Okay, so that's what C is. Now we want to solve for D. So we solved for B, we solved for C, now we want to solve for D. I'm going to go back a step. So I'm going to go back, let's go back to here. And we'll rewrite that. I'm going to do the same first step that we just did. So we're going to have E minus log F, let's see, times A, and then I subtracted B from both sides, minus B equals C to the D. Now, this is where things get tricky, because people get confused about logarithms. And I after years of trying to figure out why people got confused with logarithms, logarithms and why I myself get confused with logarithms, I think I have the answer. So if I were to ask you what the opposite of addition is, you'd say subtraction. Right? Opposite of addition is subtraction. What's the opposite of multiplication? All right. Most of you are probably thinking the opposite of multiplication is just division. Okay. What's the opposite of exponentiation? So if I were to take a to the b, what's the opposite of that? How do I undo exponentiation? This is why exponentiation, logarithms, and square roots are difficult to remember, because there's two different ways. There's not one opposite for exponentiation. If I want to get the a out, all I have to do is take the b through. I have to take some sort of square root, or some sort of root. It could be square root, cube root, fourth root, whatever it happens to be. I have to take the bth root to get the a by itself. What if I want to get the exponent by itself? That's the tricky part. The exponent by itself, in order to do that, I've got to do a logarithm. So a logarithm undoes the exponentiation to get the exponent. A root undoes the exponentiation to get the thing inside the exponent. So the a in this case. So we want to do a logarithm to get the d by itself. So here's how we do that. I'll write this again. E minus log f times a minus b equals the log, oops, I'm going to take the log of both sides, so I'm out of room here. So I'm going to take the log of this side. I'll take the log of this side. I'll get log of c to the d. Log of c to the d. Now logs have this funny property, where if I have a log of something to the something power, so log of c to the dth power, I can move that d out of the logarithm. This is just an algebraic property. So I can say the log of e minus log f times a minus b, it's a lot nicer when I have more room, equals d times the log of c. So I've effectively, d times the log of c. I've effectively pulled the d out. Now I have this log c that I can get rid of. All I'm going to do, I'm going to divide both sides by log c. Actually, let me just do it here. Save myself some writing. I'm going to divide this side by log c. I've divided this side by log c. The log c's will cancel. So I'm just left with d on this side. We cancel that, and we're left with, now this is a nasty expression. No question about that. But it's a nasty expression that I did not have to plug numbers in because I just was moving the letters around. Just moving the letters around using the rules of algebra. So we get that d is the logarithm of whole thing, e minus log f times a minus b divided by log c. Now you might ask, could we just make this one big log and say log of everything in here divided by this, so log of, can we just pull the c into one big logarithm? We can't really do that. Here's why. Let's say, let's work with this. So the natural log of e the number e, is 1. Okay, so it's saying e to what power is e? Well, it's e to the first power is e. So let's say I took the log of e divided by e. Okay. Well, it doesn't really matter what you know about logarithms. Anything divided by itself is going to give you 1. Anything divided by itself is going to give you 1. So I can't, the thing I can't do is I can't just take one big logarithm. So I can't do this. So this is not the same thing as log of just e over e. because again, anything divided by itself is 1. So e over e is just going to be 1. What's the log of 1? Well, the log of 1, e to what power is 1? That's just going to be 0. So this does not equal that. So these two things can't be the same. So I really do have to keep a logarithm up top and a logarithm on the bottom. I can't just combine the two. Just a little algebraic aside. Before we get back to our mission of solving for all the different variables in this algebraic equation. Again, all we're doing is just rearranging the letters using the rules of algebra. We've solved for D. Let's see if we can solve for E now. I'm going to go back to my top line. And we're going to try to solve for that E. Okay, so I want to get rid of, I want to get E by itself. First thing I can do, I can add b to both sides. So let's add b to both sides. I add b to this side, the b goes away. And I'm left with e minus log f times a minus b. If we add a b to it, it goes away. That means I've got to add a b to both sides, plus b. Or equivalently, it's like taking the minus sign over here, moving over to this side, and flip the sign. Next thing, we've got an a here. Want to get rid of that a. Got to divide through by the a. So I'm just going to say, let's divide both sides by a. Shoop, shoop. A's on this side cancel. I'm left with e minus log f equals c to the d plus b over a. I want to get e by itself. To do that, what I will do, I'll just add log f to both sides. Add log f here, add log f here. On this side, it cancels out. Here I just get c to the d plus b over a plus log f. And we're left with, after these guys cancel out, we're left with e equals this. Okay. Easy enough. Again, just moving the letters around. Nothing too complicated there. Last thing we want to do is solve for f. So I want to go back one step. I want to move my log f back over to the other side. Since I've already done the work to get this by itself, we'll say e minus, oops, put myself in the room, log f equals this stuff on this side. What do I want to do? I want to get log f by itself. So what I'm going to do, I'm going to move the log f over to, actually, you know what, I'm going to go back to where we were. I'm going to plus log f over here. What I'm going to do, I'm going to just move this whole thing over to the other side to be with the e so that I can get log f by itself. So that'll be, I'm going to go up. We'll go up over here. Let's see. I've got this equation. I want to solve for log f. Let's move this guy over to the other side. So that'll be, in this way, e minus c to the d plus b over a. This has got to equal log f. How do I undo the log? What's the opposite of a natural log? Well, that's taking e to some power. So the way to undo the natural log, I'm covered in chalk dust right now. The way to undo the natural log is to say if I have log x, and then I take e, exp, the exp button on your calculator to the log f, to log x, these things are going to cancel out. So I've got to take the exp on either side. I'm taking it to the, I'm taking e, the number e, not e, the variable e. I probably should have paid attention to that. But e, the number e, to the power of both sides. So we'll say this is going to be exp of everything in here and I'll do the same on this side, has to equal exp taken to the power of f. The exponentiation undoes the logarithm, so I'm just left with f on this side. These guys cancel. We've got f is equal to e the number e taken to the power of e minus quantity c to the d plus b divided by a. Algebra is very tricky. There are plenty of resources online. If you go on YouTube and search for algebraic help, usually things with logarithms screw people up. Usually order of operations screws people up. There's plenty of examples online and practice problems. Feel free to go through those and practice those. We're going to be doing a lot of this. If you have questions, stop by office hours. I am happy to help out with that.